welcome aboard, everybody. So my name is Austin Jenkins. I go by Inspector AJ on social media. Simply for the fact is one day I decided to start posting to TikTok, and I didn't want to do it under my actual name. And then I don't know where the name Inspector AJ came up, but it stuck. So we've actually started the process for trademarking and patenting. So we got some information on that too. So we're going to go ahead and get started. Let's take a peek here. All right. So what I'm going to do is I'm going to go ahead and just share my screen, and we're going to basically just kind of go over some information as far as electrical systems, how I inspect them, some safe practices, and then we're going to talk about, and I'll actually show you some real world examples on some actual inspections that I did not too long ago. So the very first thing that we're going to do is talk about the standards of practice. What does InterNACHI require? What does InterNACHI not require? So section 3.7 of the electrical standards of practice says that the inspector shall inspect the service drop, the overhead service conductors, and attachment points, service head, goosenecks, drip loop, service mast, electrical meter and base, service entrance conductors, the main service disconnect, panel boards, service grounding and bonding, represented number of switches. We'll get to that one in just a minute too. InterNACHI says that you have to test a representative number of switches, lighting fixtures, and receptacles, but I'll kind of explain why I think that you should go a little bit farther and test everyone that you find. All ground fault circuit interrupter receptacles and circuit breakers observed to deem to be GFCIs. And we'll talk about that in just a minute too. We also do have to report on and inspect the presence of smoke and carbon monoxide detectors. The inspector shall describe the main service disconnects amp rating if labeled and the type of wiring observed. And we'll go over some of that too in just a minute. And of course, it's got the information on the inspector shall report if in need of correction if any of these items have issues. As you'll notice, there's only five sections, but that section can vary widely, and it can go pretty in depth. The inspector is not required, and this is a big one, to insert any tool probe into the main panel board, subpanels, distribution panel boards, or electrical fixtures. Operate electrical systems that are shut down. That's also a big one, mainly for the fact if there's a breaker that's turned off and you turn that breaker on, you don't know why that breaker was off to begin with. So if the owners had it turned off for a specific reason, if they were doing some renovations in a different room, or if there was a safety issue that required it to be off and you turn it on, you are now liable for any potential damage that causes to any occupants or the house. Remove panel or cabinet covers or dead fronts. Ironically, if you're brand new to this, the inspector is not required to take off the dead front cover to an electrical panel. I know that a lot of people take them off anyway, and I know of a couple of inspectors that don't take them off at all. Operate or reset overcurrent protection devices or overload devices. Operate or test smoke detectors. Inspect, operate, or test any security fire alarm system component or other warning or signaling system. Measure or determine amperage or voltage other than what's labeled. Inspect ancillary wiring or remote control devices. Activate any electrical systems that are not energized. Inspect low voltage systems. Verify service grounding. Inspect private or emergency electrical supply resources. Inspect spark or lighting arresters, de-icing equipment, voltage drop calculations, exterior lighting, or accuracy of labeling. So that kind of sets the precedence on what we are required to do, what we should report on in need of correction, and what we are not required to inspect. So it's a lot of information. Electrical, in my opinion, is one of the biggest areas that can go wrong and it can go right at the same time. Electrical is the area that can kill you the easiest, okay? It's one of those that if you do it the right way, you do great for your clients. If you do it the wrong way, you can kill yourself. Simply for the fact that I don't have the exact calculation on me, but I believe it's a 1/16 of an amp, it may be even less, is enough to stop the human heart. And obviously an electrical load center, there's more than that. So if you choose to take the dead front cover off of an electrical panel, just remember to always do it safely. And we're going to talk about some safe practices here in just a minute. So, all right. So next, what we're going to do is we're going to dive just into a little bit about what InterNACHI covers to begin with. And I'm going to talk to you about some of the tools that I use. So we're going to go ahead and start with that. Earlier, I had mentioned that the inspector is required to test a representative number of switches, lighting fixtures, and receptacles. Okay. Testing receptacles is super easy. It's super fast. It literally takes all of 2 or 3 seconds, and it costs you just a few extra moments. So I say if the outlet is accessible and you don't have to unplug any personal property that has a timer on it, go ahead and test it. And I'll show you the exact testers that I use. Let me just get this pulled up right here. All right, so the first one I use is this one right here. And you'll actually see that I last purchased it June the 26th. That's because I've had to purchase about 3 of these because I keep leaving them behind, losing them, or break them. They are fairly small. This one serves a couple different purposes, okay? Klein Tools makes an amazing product. And this one, not only will it calculate voltage for you, you can also test GFCI circuits with it. So it gives you a time whenever you hit test as to how long it took that actual circuit to ground out. They're fairly inexpensive, $21, and they are extremely handy. So here's a couple of different ways to show that it's in use. And I've got some inspection photos that I will show you that show, for instance, if it has an open ground, an open neutral, open hot, or if they're switched. It's a really great product for 21 bucks. That one stays in my bag. Like I said, I've got about 3 of them, mainly because, if I'm walking through a house, or, I plug it up in one room, for instance, in a bathroom, and then I trip the GFCI outlet, and then it's on a dependent circuit, and I go to another bathroom to reset it and get sidetracked. Sometimes I leave them behind. I'm only human. The next product that I'll explain is I call them a voltage sniffer, because really that's what they do. But basically, they're a voltage detector, and this is the exact one I use. It's made by Fluke, and it's an amazing product in my opinion. Now, of course, you can purchase additional products from the inspector outlet, which we'll cover in just a second. And if you're brand new to inspecting, or if you have very little electrical knowledge, this wire gauge, it's a 7-piece with a cord that you can safely touch a wire with and not be electrocuted, because it's a non-conductor. They're great to have in your bag. They're $39.99 plus shipping, and it's a great resource to have on your person, in your bag, or in your toolbox. You can also purchase additional equipment from the inspector outlet. Again, some voltage detectors, and you can also purchase some additional equipment that can exceed the scope of practice. Like clamp meters, we are not required to use those, but they do benefit you and your client during the inspection process. So let's go ahead and dive in just a little bit more. Okay, so we're going to go to safety. So electricity kills. That is completely understandable. It's one of the most dangerous parts of a home inspection. In my opinion, it is the most dangerous, short of walking on a roof and going into a crawl space with toxic gas. Essentially, you want to do the best for your clients, but at the same time, you want to do the best for you. Okay. If you die during the inspection, that's a bad day for everybody. It's a bad day for you. It's a bad day for your family. It's a bad day for your clients. So we're going to hopefully learn a few things that will keep you safe while adhering to InterNACHI standards of practice, and that will be able to give your clients the best inspection possible. Again, InterNACHI, their standards of practice say an inspector is not required to remove a dead front cover of an electrical panel or box. My personal level of comfort, if I can touch the box completely freely and move it, I will remove the dead front cover. Now, if it does not meet the standard requirements of 3 feet coverage and I can't get a full grasp on it, then I will, invoke the standards of practice and say I couldn't remove it, and then try to inspect everything else around it. But if you can't get a good footing and have the proper clearance to safely pull that panel cover off, don't do it. Some things you want to watch out for. obviously obstructions, but you want to have PPE as well. Protective eyewear and gloves. The gloves, I'll be honest with you, I don't wear them most of the time, simply for the fact I forget. The eye coverings I do, because more than one occasion, I've pulled off a dead front cover and I've been hit in the face with dust, debris. There have been bees inside of the panel. They'll come out and hit me in the face. Do not wear nylon or polyester clothing, simply for the fact that it can catch fire just a little bit easier. And this should go without saying, but you should never allow the client to get between you and the panel. There was one time I was inspecting a house. I took the dead front cover off. I set it on the ground, and there was a gentleman that came over my right shoulder and started to point into the panel, and he actually touched the black wire going into the breaker, and he was about 1/4 of an inch away from the actual exposed copper. And I had to get away from him, because if he gets electrocuted and I try to hit him, I'm going to get electrocuted. So we had to have a little chat, and I basically set forth the standards that he will not do that. And sometimes you have to get a little forceful with your clients in that instance, because they want to see it, they want to be there, and you want to show it to them. So one thing I would recommend is to take a picture of it and zoom in so that they can see it, and then you can reference it on the panel. So just some basic terms whenever you hear me talk about this. So if you hear grounding electrode, it's a ground rod. Sub panel is a distribution panel board without a service disconnect. So usually something that is powering a shed, an exterior garage, or even in some instances, a condominium. I intermingle outlet and receptacles. So if you hear me talk about one or the other, I'm meaning the exact same thing. Service to remote panel is a feeder, hot or a live wire. I don't really utilize the phrase ungrounded conductor, so you'll hear me say hot wire. And for the same thing for a neutral wire. So if you hear me refer to black wire, that's the hot wire. If you hear me refer to white wire, it's the neutral wire. So we're going to talk about conductor sizes really fast. So most modern homes, okay, that is your typical 1 to 4 family residence. More than one on, I don't know how to really put this. It is more of a standard to have a 200 amp panel utilizing 4/0 aluminum or 2/0 copper. Condominiums are the exception. I usually see condos between 125 and 150 amps. Very rarely will I see any residential home at 250. And there's only been a handful of times I have seen homes with a 400 amp panel, 400 amp service or higher. Where I live, we still have some homes that were built in the 1800s and early 1900s that utilize 100 amp service. So obviously, if we see a house with 100 amp service, the electrical requirements back, in the 1930s when they were using 30 amp service, obviously it's a little bit different than today. As I sit here in my kitchen, I can look and see about 10 different things that require electricity. So, my computer, my lighting fixture, my phone, my watch, the refrigerator, the crock pot, the dishwasher, everything that's plugged up on the countertop, my stove, my microwave, Christmas trees, so on and so forth. So my home draws about 200 amps in total. Obviously, that wouldn't be the case in the 1930s, 40s, 50s, and so on, simply for the fact that the demand for electrical load just wasn't there. You're going to see references to the National Electric Code. Some of the things that I'll go over today do, in fact, have code violations. Some aren't. More so, again, because we are not code inspectors, we are function and safety inspectors. That's really our job, is to keep your client and their asset safe. So let's go ahead and talk about some service entrance cables for just a minute. Let me find that on here. Here it is. All right. So we have a service entrance cable here, which is, it's a typical cable going into a home. And I think I actually have a diagram. Maybe I deleted it because it didn't really apply. Okay, I don't. So on a normal residential inspection, you're going to see 2 of these cables, okay? You're going to see your service entrance cable coming into the actual panel itself. And now, depending on when the house was constructed, you may see some old rag wrap cabling, you may see some cloth insulated, but for reference, we're just going to go with your standard Romex. Now, Romex obviously is a brand, not an actual cable type, but this right here is a 14.3 non-metallic sheath cable. This is one of the most common types of wiring that you will see in a residential structure. Now, 14.3, not so much. It's usually 14.2, 12.2, 10.2, things like that. So whenever you see 14, that's the gauge of the wire, and then you see 3, so that's the number of conductors. So remember when I said earlier, you have a black hot and you have a neutral. Well, this one is a little bit different. So you've got the black hot, you've got a red hot, and then you've got the neutral. Now, oftentimes 14.3 is used in 3-way switches and other types of lighting circuits, but that's just a general overview. You sometimes will see armored cable, oftentimes referred to as BX cable. I don't usually see them where I am because mainly we don't have a lot of industrial type homes. Now, sometimes you may have exposed brick in apartments. They may have the cabling run to the exterior of the brick and secured. That's fine. And then you'll have underground feeder cable, which is utilized in underground operations. So if you're powering lighting fixtures on the outside of your home, you can run underground feeder under the ground. But these are the general wiring types that you will see in a residential inspection. So InterNACHI has an amazing gallery for diagrams, pictures, charts, and things like that that show amperage ratings for residential cables. Again, we talked about 4-aught aluminum and the 2-aught copper. And for those of you that have been doing this a while or have an electrical background, you know why, because aluminum does not have the conductivity that copper does, so on and so forth. But random fact of information, gold and silver can also be used in residential wiring. However, obviously, due to the immense expense, you're not really going to find it, but it can be done, and a lot of people have talked about it. That's why gold is utilized in a lot of computer chips because of its high relative conductivity. But you can see a lot of good information as far as amperage ratings and the size of the wire for both copper and aluminum. So if you ever get an opportunity, I strongly recommend that you check those out. So going back to InterNACHI's electrical inspection course, we're going to go back to some home inspection safety. So injuries occur most often with electrical shock and actual cuts. So, the gloves, whenever you remove a dead front cover, oftentimes have sharp edges on them. So you can actually cut yourself on those as well. So we'll talk about some potential damage that you can see going in. And if you see some of this stuff, you should probably not continue the interior inspection of a dead front cover, or excuse me, of a panel board. So if you have scorch marks on the dead front cover, that usually indicates past or present arc flashing. If you see rust, usually on the bottom of the electrical panel, that indicates that water is intruding into the panel, and it could be unsafe for you to actually open. Whenever you do approach an electrical panel, it's a smart idea to brush the outside of it with the back of your hand so that if it was energized, you can easily pull away rather than actually just grabbing the door or grabbing the sides. If you see uninsulated wiring going into the panel, that's usually a red flag. Excessive dust, dirt, and debris inside the panel, and of course, any signs of water inside, around, below the panel, which can lead to shock or electrocution. Time and time again, I have done inspections where they have the plumbing literally running just inches above the panel. And oftentimes, if the electrical panel is in a basement, sometimes there's standing water. And you don't really need to be a scientist to realize that water and electricity doesn't mix. So, but we talked about arc flash. So let me just kind of explain what this is. Basically, it's an unexpected flashover. Let me move this out of the way real fast. An arc flash occurs when a flashover of electric current leaves its intended path and travels through the air from one conductor to another. Now, in some instances, you as the individual can be the conductor if you're not careful. How serious is an arc flash? You could die. They have 3 factors that can determine the severity of an injury caused by arc flash, and it's the proximity, how close you are, the temperature, and the time it takes for the circuit to break. Oftentimes, if you'll see linemen working on light poles outside, you'll have one of them with a rod ready to pull the other one away just in case, something goes wrong whenever they flip the switch. And we'll just go over some precautions. Like I said, assess your risk tolerance. If you're comfortable with taking off the dead front cover, so be it. Wear PPE. Check your surroundings. Again, the electrical inspection doesn't necessarily start inside the panel. It starts outside the panel. Use appropriate tools. Protect your clients. That's probably one of the most important things is to protect you and your clients, because not everybody has the same level of knowledge that you have going into this. Okay. So next, let's go to some things I look for whenever I do an inspection on a house that's either had some renovations or a new construction, pre-wall drywall inspection, or excuse me, pre-drywall inspection. So most oftentimes, electricians are going to bore holes through the studs within 1.25 inches of the edge of the stud. And they're human. I get it. Sometimes it's a little bit shorter, it's a little bit longer. So if the hole is less than 1.25 inches from the edge of the stud, you need to have a metal plate. And essentially what this is when the drywallers come and they put a sheet of drywall up and they attach the drywall screw, or they attach the drywall with a drywall screw. Once that sheet of sheetrock is on the studs, they can't see where this is. And usually drywall screws are not going to penetrate a metal plate or go further than 1.25 inches as long as the wire is buried in the middle of the stud in most instances. So some of the things that I look for, again, when I go into a pre-drywall inspection, I always look the very first thing to see if there are metal plates installed. And if there's not metal plates installed, that's when I, go take a tape measure and actually go measure the stud from the edge to the edge of the hole. So let's go ahead and take a peek at some information about GFCIs, because I talked about that earlier, just in case you don't know what they are. A GFCI is a ground fault circuit interrupter called a GFCI, and some electricians refer to it as a GFI. Either term is interchangeable. It's perfectly okay. They were invented in 1973, and truthfully, they've saved countless lives. And there's a really cool chart. I think I've still got it pulled up. If not, I can find it in just a minute. That shows when specific areas they were required by the National Electric Code to be installed. For instance, on a kitchen, most kitchens require 2 dedicated GFCI circuits, assuming that it's in the path of water. Really, you can think of path of water equals GFCI. Okay. If you have an area that could get wet, it needs to be protected either by a GFCI outlet or a GFCI circuit if it's downstream, which is one of the most common that I see in new constructions. You can walk into a brand new house and it won't have any GFCI outlets in the kitchen, but all of those circuits are on GFCI breakers, which is perfectly fine because they're protected the exact same way. Okay, so let's go ahead and take a peek at, where did I have it? This one right here. This one is a big one. So more often than not, when Joe homeowner decides to run some wiring in their new basement, their attic, they rewire a garage. Oftentimes they purchase, the little white cable staples, and they decide to do more than one cable per staple, which is okay as long as you get the staple that's rated for it. I've come across many situations where they take the cable and they actually turn it vertically. So you've got the 2 conductors in a vertical pattern with the ground in the middle, which is actually a code violation per the National Electric Code. Most of the time, however, due to the way that the staples are made, the wires will sit flat and flush with the finished surface, and that's okay. So if you see something like this, that is perfectly fine. If you see something like this, that needs to be written up because it's putting unwanted pressure on the interior conductors, and that can actually lead to a short and a fire. Whenever you inspect metal staples, and usually in older homes, one thing you want to look out for is to make sure that they're not compressing the wire too tight. You see, whenever you get a cable staple that's compressing the wire too tight, it creates a damage point on, and I'm just going to use the term Romex, it creates a damage point. And over time, the staple will rust, and the rust can get sharp, and it can actually cut the cable. It'll cut the exterior sheathing on the actual conductor itself. And at that point, it can arc and it can start a fire. So some of the things you want to look out for whenever you inspect visible electrical, it's either stapled to studs or to sheathing in some instances in an attic. You just want to make sure that there's not a lot of tension on metal cable staples on those types of conductors, because it could potentially cause a fire in the future. And we all know that, once something like that happens, you're at fault. All right, so let's take a look at some practical issues. And these are some information, or excuse me, some examples that are real world. We're going to look at some sample reports that I've compiled, and then we're going to look at some reports that I have actually done in the last 2 months with some of these electrical issues. So we'll go ahead and take a look at some of the samples first, and you're going to see those are generated with a 1, 2, 3, 4 Main Street. So here we are in my electrical section, and some of the things that we're going to look out for, you can see on the information tab. I have covered the information that's required by InterNACHI, also include limitations, and I put the standards of practice in there too, so that the client will actually be able to see what I am required to inspect. So in this instance right here, we had a ground rod that was exposed. Now, there's a lot of debating if they're to be exposed or not, but per the InterNACHI standards, the ground rod should sit flush or just slightly below grade. So we had an open knockout. And you can tell by this sub panel, this thing was in great condition. Didn't need any type of maintenance at all. They actually did purchase a knockout from a home store, and it had fallen out. So that was a good day right there. We had some unsecured live wires. These were hot. So they decided to splice them together in an area. They didn't use any electrical tape. They didn't use the junction box. They didn't use anything like that. We had multiple outlets throughout that house with hot and neutrals reversed, which will actually still allow a circuit to function, but it is wrong because it could inadvertently shock you or lead to some serious damage to your electronics that you plug in. I also include, especially if it's an older home, now it's not really a deficiency per se, but it's more of a recommendation that the number of outlets does not meet today's standards. So basically, you put your finger on a point on a wall, and anywhere within 12 feet, you should have an outlet. I believe it's 12 feet. So this particular outlet right here, I remember walking through this house, and this was in a hallway, and there were 2 other outlets fairly close by. And I thought to myself, I've checked a representative number of outlets, why should I bother to test this? Well, I pulled, my outlet tester out, I popped it in, lo and behold, that outlet didn't work. So it took an extra 2 seconds. I exceeded the standards of practice by testing, more outlets than required. And turns out I'm glad I did, because go figure, this probably would have been that inspection where the buyer calls me and says, hey, we've got an outlet that doesn't work. You missed it. So we'll go to the next one. So this one right here, this one had an old school fuse, main fuse disconnect. So fuses can be extremely reliable. Unfortunately, they can be defeated. I have owned homes in the past that have been on old fuses, and what the previous owner did is took pennies and dimes and actually put inside of the connectors to allow the circuit to continue when it shouldn't have. We had multiple knockouts open. As you can see right here, especially if you have children, they could easily stick their fingers in there, become electrocuted, because the bus bars on the inside are literally just right here. I did recommend that this panel be replaced simply for the fact that it had a lot of electrical deficiencies in it, and just due to the age between the panel itself and the main disconnect with the fuses, I strongly recommended that they be replaced. So anytime that you come across fuses with today's electrical demand, it's okay to recommend replacement. It's okay to do that. I know a lot of electricians will say, it's not needed, but again, your job is to protect your client and the house while protecting yourself. We also had in the attic, again, some open splices that didn't have electrical tape. They weren't in a junction box. If an animal gets a hold of those, that can be a really bad day. We had some improperly installed outlets. The junction box was protruding out from the island, and it was loose at the time. None of the outlets on the outside of the home were GFCI protected. Multiple outlets in the home were also neutral and hot reversed. This one had a lot of electrical issues. We actually did recommend, or we spoke with an electrician who also agreed with everything that we had wrote down to replace pretty much rewire the entire house, which was to be expected. This one was one of my favorites. So one thing you want to look out for when looking at an electrical panel is to make sure that the screws holding the dead front cover on do not have sharp edges. They need to be blunt tipped. And just because you cut the tip off, they still can have sharp edges. Usually what I've done in the past is if I'm working in a house, if I'm not inspecting it, if I'm doing some electrical work in the house and I run across screws that are sharp pointed, basically I'll take an angle grinder or a sander and just put a blunt tip on them. It takes no time. Here again, we had another ground rod that was above grade, and we had some missing screws in our panel. Now, of course, you do need to write that up because that can be considered a point of entry. And the breakers were not the same brand. So that's one thing I like to write up all the time, is that the breakers aren't the same brand. Now, I get that breakers can be retrofitted between one panel and the next, but they're not designed to. Square D breakers should be going into a square D panel, GE breakers into a GE breaker panel. I also include information about tamper resistant outlets, and I include this handy little diagram that if a house doesn't have tamper resistant outlets, what can happen. So I always do recommend an upgrade in most instances. This one right here, this wire was dead. They actually terminated it deep inside the house, but I did recommend that they go ahead and secure it because the next person may not know that it was dead. We had some exposed receptacles, and I really like this. They actually attached this fixture on the outside of a home. Didn't have any sealant, didn't have anything. It actually it stopped working. It shorted out long ago. So we will move on to this one. If it's the one I'm thinking of. Yes, it is. So this house was built in 2002. I inspected it about a week ago. It had a service meter disconnect based combo. So it had the service meter along with the disconnect. So I don't know if you can see this. When you lifted up the cover, there was nothing protecting you. You can see that the two screws right here were missing, and they basically there's a panel that goes right there that protects the interior of the wires, the conductors, and so forth. So obviously did write that up as the cover was missing, and we had a corroded ground wire. So you can see right here, which I thought was actually really cool, the corrosion kind of starts right here. So that's the main point where the wire touches. So if anybody can remember electrolysis, I believe it is, or galvanic action, one of the two, they're really interchangeable, but I can't recall the exact terminology, but that's taken over. And with gravity, it has corroded that ground wire. And you can see all of the dead insects and bees and things like that. So I did recommend that the ground wire be replaced. Going into the home, they had removed the track lighting system and left the exposed wires capped off, but they were still exposed. Going into this house right here, this one was a few weeks ago. And as part of the standards of practice, we also do inspect smoke detectors and carbon monoxide. Obviously, when a smoke detector turns this shade of yellow, it is time to replace. Now, one thing I like to do is whenever I go into a home and I see that the smoke detectors are either not brand new or they're not installed yet, I always recommend replacement. And the reason I recommend replacement is whenever you move into a new house, unless it's a brand new construction home, you don't know what the previous owners did. And I say that because of this. So I inspected a house one time and I was trying to test the smoke detector, even though we're not required to. I was pushing the button and nothing happened. Well, I took the cover off. They had a battery in it, but the previous owners had cut one of the wires on the inside of the smoke detector. So to the untrained eye, it looks like the smoke detector worked, had a battery in it, but the problem was it it didn't work because it was tampered with. So anytime that I get a house that's either not new construction or less than or older than 5 years, I always recommend replacement of smoke detectors, simply for the fact that you don't know what the last person did. Going into the crawl space of this specific house, we had wires that were just draped across the ground. They had very little securing clips. It was just laid out everywhere. They had taken 2 wires, you can see right here, that they actually spliced them together, which ironically, they were both 10 gauge. So we have a 10 gauge wire with white sheathing and a 10 gauge orange wire. So I did not write that up as far as 2 different sizes, but I did write it up as damaged, or excuse me, as an improper slice as well. I wrote up Romex on the outside of the house simply for the fact that it was not UF rated. Going back to this house. All right. So does anybody, if you're watching this, obviously, what do you see wrong here? Basically, the electrical panel does not meet clearance requirements. You know, there's not 3 feet of clearance on the interior, and I could not safely remove the cover, but did I? Yes. Simply for the fact that I felt safe enough to remove the cover, so I did it. One thing, surprisingly, that a lot of people do not write up, but I still do, is the fact that a white wire, in most instances, like I said, it's a neutral wire, was used as a hot conductor. Now, most oftentimes, whenever this happens, it's because they're using it on a 220, 240 circuit. And the reason they do this is because they can save money. Instead of buying like a 12-3 wire or a 10-3 wire, they just utilize the white conductor as a hot conductor. Now, you are allowed to do that, but it does need to be marked with either black ink or black electrical tape. So that's actually one that I see all the time. I did notice an area of arcing on the bus bar. There wasn't anything in the neutral terminal, so I'm thinking it was an old circuit that had been taken out or replaced, but I did notice some arcing right there on that lug. The home did not have, the home had multiple outlets that did not have a grounding conductor. So that's one thing that, again, that Klein Tools outlet tester that I was showing earlier would be able to show you if it did not have a ground or had an open neutral and things like that. Moving on to the next one. This was a brand new construction home that was just finished 2 months ago. So we have the neutral wire, or excuse me, this one was the neutral wire. Did not have all of the aluminum strands under the lug. So that's, again, one thing that I do need to write up, simply for the fact that not only is it brand new construction, this passed inspection by the deputy state electrical inspector, and each strand of that aluminum wire is there for a reason, so they all need to be under the lug. And of course, we can also see some antioxidant paste between the material and the lug itself. Going to this inspection, so this one was actually really interesting. As you'll notice, I'm actually starting on the built-in appliances portion. Simply for the fact that one thing I do when I go into a home is the first thing I do is turn on the oven. So I turn on all 4 burners, and the moment that I did that, the stove went black. So I go to the electrical panel, and it turns out it's only on a 30 amp breaker. Most stoves are usually, if they're electric, top and the actual oven itself, they're usually on a 50 amp breaker. So you can see we have a 30 amp breaker with 10-3 wiring. So that's one thing that I wrote up, and this actually damaged that breaker. It would not reset, and it would not reset, or excuse me, it would not reset, and it would not go back to the operating position. So in that instance, that breaker will need to be replaced. And I told the buyers that if they were going to continue to utilize that circuit, they need to have it rewired so that it can safely meet that stove's required ampacity. So that one was actually really interesting. So going to the electrical section now, which ironically they were in two different areas. So we have some corrosion on the meter base. That's usually an indication of a high area of moisture. Now, of course, this one is tagged, so I could not actually see the interior of it, but I would have loved to. And this electrical panel was actually in a little hidden compartment, really. It had magnetic locks on the bottom, and that's where they hid it. But I wrote it up simply for the fact it did not meet clearance, because it did have obstructions to the front and to the right side of the panel. Some inspectors write up multiple grounds and neutrals per lug. That's more so of an experience type thing. So the National Electric Code, if I'm not mistaken, the most recent edition does not specify that you cannot have more than one neutral or one ground per lug, assuming they're the same size. For instance, if you have a 12-2 wire and a 10-2 wire, and you put those neutrals under the same lug, obviously that's an issue, simply for the fact that the wire sizes are different and you do have torque values associated with those lugs. But if they're the same size, sometimes it's okay. But one thing I always write up is if there's multiple neutrals or grounds per lug. We had some uncovered junction boxes. They just left the covers off of all of them. They installed the wiring and then just left the covers off. You can see those here. None of the outlets on the exterior were GFCI protected, so obviously that gets wrote up as well. And here we had an open neutral, and you can see that right here by says open neutral. So going back, I think that covered all of the practical inspections. Yeah. So we're about 42 minutes into the webinar, so we'll be wrapping it up here in just a moment. But for those of you that don't know me or don't follow me on any form of social media, like I explained at the beginning of the webinar, so I go by Inspector AJ, and I kind of got started by accident, posting some videos that unintentionally went viral. So for those of you that have TikTok, that's my biggest platform. I also post on Facebook as well as Instagram as well. Do very little on YouTube, not much. So if anybody has any questions about social media, please feel free to reach out as well. But one thing that I will also show you, for those of you that don't know, is, really this is TikTok. It's, I've got 1.8 million followers on TikTok, over 250,000 between Facebook and Instagram. So that really finishes the webinar for today. So we're going to move into kind of a Q&A type thing. So what we're going to do is ask some questions, get some answers, get some feedback, and we'll just kind of talk about it a little bit. So let's take a peek here. I think we got AJ Vega here too. So I think he may be fielding some questions. So let's just go ahead and have a little Q&A session. Zach Mills says, will this be available to watch after recorded? Yes. Oh, I see AJ's already responded. Yeah, it will be. When it's open neutral, it means it's non-secured. What does that mean? So on an outlet, you've got terminals on the back. You got a hot wire coming in, you've got a neutral, and you've got a ground. Usually an open neutral means that either at some point between that connection and the panel, that wire has come loose somewhere. Most oftentimes it's at the actual outlet. I've seen in my experience outlets that are called backstab, which basically the conductor goes into the outlet, and you don't have to wrap it around and screw it. It literally just kind of fits in like a shark bite connection. They've come loose at some point. Details on the energy audit I mentioned earlier. All right, so I will go ahead and kind of show you, Dallas, what I was talking about with that. So if we go to NACHI.org, this is your dashboard. So if you're an InterNACHI CPI or CMI, you've got this dashboard. You've seen it before. So if you go into the apps section and you click on home energy report, what this is going to do is it's going to bring up your most recent home energy reports, and you can click on it, and I'll view the report in a new window, and it will load the report. Usually takes about 10 seconds, and it will provide cost estimates and how to save money. So for instance, these are the potential estimated costs for heating. It's going to be $1,208, cooling, large appliances, small appliances. And this is basically information that I key in from the actual inspection itself. Whenever we key one in, it you put in the address and it finds you information close to where the most recent, what's the word I'm looking for? The most recent energy information is posted. And that tool is completely free for all InterNACHI members. and you put the information in, and it'll ask you, year of HVAC system, year of water heater, BTU, things like that. And it literally takes 3 or 4 minutes to compile. I click compile, take that link, put it in the report. The clients can click on it and see what they're going to be expected to pay in the future. Now, of course, those numbers aren't guaranteed, but they do provide a good rough estimate. Do I do energy audits on all my inspections? I do. Well, it's not really an energy audit. It's just an energy report. That's one thing that I do to my clients. It's free. It costs me nothing. It's a good tool for them, and it kind of sets me apart from my competition as well. Canyon, before I answer your question, I think we had another Q&A pop up real fast. William says, how do you feel about replacing blanks and blunt screws on the dead front cover as a courtesy? So that's a really good customer service thing that you can do. I actually have a baggie in my truck that I keep screws in, because there are some times that the electrical panel is like recessed into the wall, and when I go to take a screw out, I drop it down to the wall. And if I need to replace it, I'll put one in. But if I've got an extra screw that can fit, like a GE or a Siemens panel, I will throw in, I'll report it that I put the screw in. And then I may even tell the seller, be like, hey, I put a screw in your panel. I hope that's okay. Teresa, how do you safely remove a panel cover? That's a really good question. So the first thing you want to do is get your feet steady. Let me see if I can pull up electrical cover safely. So the one thing you want to do is get your feet in a good position so that you're not stumbling and you're not tripping. I think InterNACHI has a picture of how to do it. InterNACHI.org/gallery. And then you can also purchase magnets. I know a lot of people use magnets to stick to the cover itself. And then whenever they actually get ready to take it off, they can usually hold on to it with 2 hands and then pull it off, so that way they don't have to actually grab the panel itself. I can't find a picture of it, but essentially it's literally clicked on it right there and you just move it off. I guess that's one thing that I should have covered, but you basically remove the screws and just take the cover off. And of course you don't stick anything in the panel itself. So if I use the Spectora software, do you know if it's possible to add energy report? Yes. If you want to send me a message on any form of social media, I'll show you how. I use the magnets and they are a game changer for safety. So I'm glad you do, Zach, because I've thought about ordering some, but I just haven't got around to it. So if you like them, I would really love some feedback, because if you like it, I'm all about changing things and bettering myself safely, of course. So on open junction boxes, they aren't critical. So Matthew, that's kind of a two-way street, man. They technically are, because they could, have damaged conductors. They could cause some issues if some debris got into the junction boxes. But at the same time, you can go to the home center and buy them for less than $1. And I do tell my clients that I tell them that I have to report it as an electrical issue because it's a hazard, but at the same time, it's going to cost you less than $1 to fix. So that's where that communication comes in handy with your actual clients on sites. Michael, on 4-point inspections for insurance, the form has specific requirements, but electrical is so important that you should check outlet switches, especially GFCIs. Absolutely, because GFCIs are mechanical, so they can fail. I've done countless inspections where I've plugged in my tester, I've hit test, and the entire outlet just stops working. And I've actually got a little disclosure that goes out in the initial emails to the listing agent that basically says these are known to fail at times. It's rare, but it does happen. And that's just one of the things that failed under normal operation. So let's see here. Jonah, regarding panel work, the best advice I ever received was never put both hands inside an energized panel. Absolutely. Absolutely. Do I ever reconsider writing up a deficiency based on the age of the home and the code that was found around the time? The GFCI, yes. So for instance, if we have a home that was built in the 50s or 60s and it went through an electrical upgrade in, let's say, the 90s, and it doesn't have GFCIs in the garage or in a laundry room, I will note it because it is technically a deficiency. but I won't make it to where it's in a red, hey, you need to look here, but I will say that it needs to be replaced and to be updated. Just reposting here because I was in the wrong chat. Okay. No worries. But yeah, so as far as when it comes to electricity can kill you and the occupants faster than anything else in that house. So when in doubt, take a picture, flag it, look it up, report it. InterNACHI has an amazing emergency forum that you can post in. I monitor it, a couple times a day to try to help out as much as I can. James, you're on here. Oh, I haven't seen you since California, buddy. I hope you're doing well. I have watched the GFCI pop and start to smoke brand new unit. Yeah, yep, they will. Time and time again. So I was actually inspecting a newer construction. It was built in 2016. It had an AFCI breaker, and of course I test those. The moment I hit trip, it popped and smoke started to pour out the breaker. So unfortunately, they do break. They are mechanical devices, and it's something that you, as the inspector, would need to write up, because essentially you're not doing your client a service by downgrading or downplaying a deficiency. You can tell them roughly what it's going to cost to fix. Like for instance, an uncovered junction box, it's $1 to fix, but the problem is, a lot of people may not feel comfortable replacing that or putting that on. I've met countless people that don't know how to change faceplates on light switches. So that's another issue that really breaks down to how well you communicate with other people. Let me just make sure that I've not missed any other questions, because I don't want anybody to feel that they have been left out, because we still have 65 people on the webinar. Here we go, Bryant. You mentioned that the GFCI outlet and the certain piece in the panel do the same function. What does it look like and what's it called? So let me go ahead and share my screen again. And what I will show you, sorry about that. So what I'll show you is a GFCI breaker. And that's this right here. So a typical GFCI breaker will also have a test function as well. Okay, that is how you can test the outlet or test the circuit. Now, a GFCI outlet it doesn't look the same, but it functions the exact same. It's basically you have a test and reset button. Whenever you test it, you'd press the small button on the left side that says test, and then to reset it, and you'd usually see a little amber or a green light. Now, whenever it gets back to the point to where they do the same function, you would have either a GFCI outlet on a normal breaker, which is a standard single pole breaker without any buttons, or you would have a regular outlet on a GFCI breaker. So you're going to have one or the other, and essentially they do the exact same. They function the same, they test the same. The only downside is if you're in a larger house and you take your outlet tester to the kitchen and you test one of those outlets, you have to walk to the breaker panel to reset it every single time. Now, the only downside with a GFCI or AFCI breaker is you don't reset them like normal. Okay, you actually have to take the breaker, because when it usually trips in the neutral position. You have to take it all the way to the off position and then back to the on position. And what I like to do is, whenever I'm inspecting a house and the buyer is present and I test an AFCI or GFCI circuit and it has one of those breakers, I show them how to reset it, because I have been called numerous times by buyers saying, hey, it tripped, it's not working, it's broken. I'm like, well, take it, move it all the way to the left and then all the way back to the right. And that's how you reset them. But you would normally test that in the process of your inspection, so you should be good at it at that point. Now, of course, you do have to disclose to the sellers in that instance. For instance, if they have clocks that are plugged up in living spaces, if they have things that are programmable, or if they, I've seen one house that had an AFCI breaker in every single position, and they were working from home that day. So I told them, that's like, you're going to lose internet for about 10 minutes, and I tested every breaker. So that's one thing that you have to do. Now, of course, this right here, we literally covered, a mile wide and an inch deep. We covered a lot of stuff tonight. Okay. Electrical sections, there are so many issues that really we could do a webinar every day for a year, and we would probably just still barely scratch the surface, because there's so much to cover. So please feel free to reach out to InterNACHI inspectors and in the forums and check them out. Wayne asks, do I report on low voltage? Yes, I'm glad you mentioned that. I didn't have it pulled up, but doorbell transformers, for some reason here recently, I have been seeing doorbell transformers inside of electrical panels more often than not. Now, you cannot have that. Per the National Electric Code, that is a code violation to have a low voltage system next to a high voltage system. So that's something you would write up, is that the doorbell transformer would need to be moved to the outside of the panel or relocated. Is it common for exterior GFCIs to trip interior lighting? I've run into that instance quite a bit, actually. They had a it was the dining room, and they had the main light fixture on the same circuit as a patio GFCI, and the lighting fixture was downstream. So that outlet got tested, and then they couldn't figure out why the interior lighting could not work. So sometimes it's a lot of trial and error to walk around and look to see if you see amber lights that show that it's being tested. I meant 110, 120 that test low. So yeah, so most modern circuits operate in the at 110 volts. So, but they operate usually kind of in a range. So when I test a circuit, if it operates at 118 to 125 volts, that's okay. If it falls below that or higher than that, then that's something you would need to report on, because normally those systems are designed to function within those ranges. Even though they say they're 110, they can usually function around the 125. So yeah, that's something you would need to report on if it exceeded those ranges. What's your opinion on doorbell transformers double tapped at a breaker? I don't like it. What I would recommend is that they would take the wire. Let's say, for instance, if they tapped the transformer in on a 15 amp breaker, okay, they're going to take a conducting wire to the breaker itself. They're going to take the wire, and then that's where they're going to splice it in. Because if you look at it, you're going to have stranded aluminum going to that transformer, and then you're going to have, more often than not, a single strand of copper going elsewhere. So right there, you've got, two dissimilar materials, and I personally would not want that in a breaker. I would like to see that spliced on the outside off of a different wire. Got about another minute and a half. So if anybody has any questions, throw them out here. Okay, never mind. We got some in the Q&A section I didn't see. I tested a GFCI in a kitchen, and it did not trip the first few times I tried it. Pressed the button repeatedly. It was decline, but then it did another time. How would I approach that issue? So in that instance, I would report it as the GFCI failed to trip adequately, because it is supposed to trip in just a fraction of a second. And the very moment that it doesn't trip with either your tester or you pushing the test button, that outlet is defective and needs to be replaced. Solar panels. So solar panels and photovoltaic cells on a roof are outside the scope of inspection. I have not seen any in my area that I live in. Now, there are solar panels, but they are outside the scope of inspection. So unfortunately, I don't have any information how to inspect them at this time. You're very welcome, William. David, it's my pleasure. Thank you very much for attending the webinar this evening. I appreciate that. Yeah, please feel free to reach out if you have any questions, guys. TikTok.com/@inspector_AJ. You can find me on Facebook. You can just search Inspector AJ or search Austin Jenkins. You can find me on Instagram, instagram.com/inspector.aj. I get 100 messages a day, and I try to respond to as many as I can that are legitimate. So guys, please, if any of you have any questions at all, please feel free to reach out. I'm happy to help any way I can. If you have questions about electrical situations or something that I can answer, or a video that I post that you have questions about, please feel free to reach out. And also reach out to the InterNACHI forum. It's an amazing thing that we have such a huge network of inspectors that are willing to be mentors and to help out. And thank you to the InterNACHI staff for inviting me to do the webinar. James says, thanks, love the background. So off topic, so the other day I applied for and received my certified master inspector title. So by the time the graphic was created, I was still a certified professional inspector, and then I got my certified master inspector. So, InterNACHI is also hosting the Pro Inspectors Convention 2023 in Atlantic City, New Jersey. So I hope to see every single one of you there. Hopefully InterNACHI will invite me back. Hopefully I didn't ruin my chances whenever we went to California. But no, even if they don't invite me back, I'll be there on my own dime. I don't care, because I really want to go to that. Because I really like to meet all of you, especially if you follow me on social media, because it's always a blast, to meet and shake hands with people that follow me on social media, that just approach me. It's a surreal experience to be recognized outside of my own house. David, do you have to complete a number of inspections to achieve that level? Yes, you have to have a minimum of 1,000 inspections, or a combined 1,000 inspections plus education requirements, and then you have to have been in business, I think it's for at least 3 years, to do that, or been licensed, or be in business for 3 years. 21 years with InterNACHI, also a CMI. Well, awesome, Bob. Well, thank you for joining the webinar. If you've been here that long, you probably didn't learn a thing. You probably could teach me a thing or two. But guys, again, thank you all so much for attending tonight's webinar. And if you guys have any questions, like I said, please feel free to reach out. I'm happy to help any one of you. So guys, be safe. And if you need anything else, please just let me know. Thanks, guys.